All right, morning, everybody. Really excited to welcome you to our third Exploring ChemE Careers panel. This one's our computational data and digital technologies panel. So we have a fantastic lineup of alumni who are here to speak with us today. And then, let me get, there we go. And we're going to have this panel moderated by Tucker, who is a postdoc in Professor Fettner's group and works on the research side of a lot of this space. And so Tucker will give a little bit more of an intro and then introduce our panelists. So Tucker, I'm going to hand it over to you. We'll turn our videos off on this end. Y'all are all spotlighted up on the big screen. And then Nicole and I will moderate chat for you as well. Thank y'all for being here.
Great, thanks so much. And I can't see the room, but hi, everyone. Thanks so much for coming. I'm really looking forward to this panel. As was said, I'm Tucker Bergen. I'm a postdoc with Jim Fettner. And I also have, my PhD is in chemical engineering. But one of the big reasons that I ended up choosing to come to the University of Washington for my postdoc was because of this interest in data science. This is something that, if you've only just been exposed to chemical engineering, if you're only just getting started, you may not be aware of this trend, but data science is really picking up across the entire field and across many fields right now. And so the opportunity to learn data science in a chemical engineering context is something that was really exciting to me, as I'm moving forward in my career. And the University of Washington is, one of the leaders in that space. So I'm really excited to hear from, some of our alumni here in that respect. And I think with that, I'll let them introduce themselves. So we'll just go in alphabetical order. You want to go ahead and get started, Nick?
Hi, everyone. My name is Nicholas Iverson, class of 2016. After graduation, I went to a company called Capstone. It makes a suite of softwares that's used in industrial facilities for historizing and visualizing and manipulating data. So heavy in paper industry, heavy in oil and chemists, and just all over the place for general use, for them to be able to look at and troubleshoot their processes with that data. So I was an implementation engineer for a couple of years doing that, and now I live in Nuremberg, Germany as a technical sales engineer. So as a technical resource for the sales team.
Great, thank you. And next we'll have Kate.
Hey, good morning, everyone. I'm Kate Schultz. I'm a data scientist at Pacific Northwest National Laboratory based out of Seattle. And I was class of 2017. So actually Elizabeth's very first class teaching. And I went on after graduating to get a master's in computer science, because at the time, there hadn't been options yet to take data science focused courses as an undergrad. I believe those are in place now. So, for me, my best option was really to go on and kind of learn those skills in grad school. And I just did a master's in CS with a focus in AI and data science. During that period, I started a co-op with PNNL with a computational chemistry group. And that's really informed a lot of the work that I've done since then. After I graduated with my master's, I was hired on as staff full time. So I've done a lot of research and analysis and software development in the areas around like protein small molecule interactions, chemical space analysis, some related fields, moving in a little bit to computational toxicology as well. And applying AI and some other data science techniques in a lot of those areas. So I'm very happy to be here. Thank you.
Great. And lastly, Sanchit.
Yeah, hey everyone. So I'm Sanchit Gad. I graduated from UW back in 2018. Currently based in the Bay Area, where I'm a product manager at a company called LeanTaaS. So I actually started my career doing more of like informatics data analysis work. I was at a startup called Health Pals, where I was doing that. I was in that role and working on basically analyzing like EHR data of different patients in the country, and using that to uncover insights that we worked with like pharmaceutical companies and healthcare systems to basically implement and improve patient outcomes. In my career, though, I've been more interested in product management, so I've switched away from doing, analysis to product management. So currently at LeanTaaS, I'm an infrastructure PM. So that means the things I focus on most are application performance, scalability, security, those kinds of things. And so most of my day-to-day work is revolving around, proposing, gaining alignment, and delivering on initiatives to improve those three areas. And working a lot with our developers and product designers to make sure that the projects I'm pushing for are done in a smart way from a technical point of view, while also not compromising on, the experience of using the product for our users. So yeah, really, really excited to be here and talk to you all.
Thank you all so much. Did you say EHS data? What is that?
EHR.
EHR.
Electronic health record, yeah.
Oh, okay, great. Sorry, I just hadn't heard that. Makes perfect sense. Okay, great. So what we'll do now is we'll just move into a section of questions for our panelists that are kind of preset. And we'll just go through one by one. So let's see. The first question is, what is your day-to-day like in your current role? And what tools, software, or programs do you use in that role? And then how has that evolved since you started your job? And we'll go in the same order as the introductions, just to keep people from, their voices getting tired. So go ahead, Nick.
Right. So my day-to-day is typically, maybe, quarter of its meetings where I might be talking to new customers and doing demos or speccing out, what a new sale is going to need. We're helping the salespeople do estimations of work. So how much is this particular thing is going to take? And then the rest of it is actually doing a lot of content creation. So it's either content creation directly for a customer where I'm doing something that's a little bit more technically oriented that just requires, attention to someone who's been there for a long time. So making new displays, new calculations, setting up, I do a lot of, I guess, I might be more of a data engineer, so a lot of my work is setting up new data sources and connecting historians. And then on top of also the sort of custom-oriented content creation, it would be sort of sales-oriented content creation. So managing our virtual machines that the salespeople use for demos, creating new demo content. And otherwise, just making sure that they have the tools to talk about and effectively demonstrate data work.
And are there any particular programming languages that you're using?
Yeah. SQL. I use a lot of SQL. I really like SQL. SQL is really cool. Relational database languages are really neat. And then I would not say some of the things that I use typically are not going to be things that other people use, not because they're bleeding edge, but because they're the opposite of that. So I use a lot of VB.NET, VB6. So nothing super crazy, but I think SQL is probably the more relevant thing to data science.
Great. All right. Thank you so much. Then the same question for Kate.
Yeah. So my day-to-day revolves around, I certainly spend some time in meetings as well. So one thing about, working in a national lab is you collaborate with a lot of different groups, a lot of different people. So, on various projects, I'll be collaborating with, with different groups at the lab, but also with academic groups as well, a lot of those. So, and that's one of my favorite things about the job, actually, is all those different collaborations I get to work on. But that does, entail a lot of meetings for sure. Another thing I, spend time on is improving software or, workflows that I've been working on for data analysis, or, adding new modules on, for example. And I use Python too, by the way. And I use Jupyter Notebooks a lot too, as kind of a first step in that pipeline. And then working on publications too. That's something that from time to time, takes out a big chunk of my day-to-day. And then finally, I've kind of one thing that's new actually that I've moved into is working on grant proposals once in a while. So I actually just got my first big grant proposal funded, which is pretty exciting, but that took, time away from the technical work that I was doing before. So in some ways, that's my role is starting to evolve in that direction of doing a little bit less technical work and a little bit more sort of like PI type work.
Yeah, it's very interesting the ways in which national lab work can seem very similar to academia in some ways with regards to publishing and grants.
Absolutely.
So definitely an interesting perspective. Thank you. And then last, will you answer the same question, please, Sanchit?
Sure. Yeah, so I think similar to Kate, my days can be pretty meeting heavy. The thing with product management is that whenever product decisions are made, everyone kind of has a voice in the room. And my job as the PM is to make sure everyone's concerns and opinions are heard and accounted for. And so that can take on a bunch of different forms. Like, for example, if we're getting close to launching a feature, then it's going to be talking a lot with marketing to see how we're going to market this new feature, talking with our customer support team to see if there's any impact to how our users are already using the product. Daily collaboration with our software engineers and our designers to make sure that different features that are in progress are being developed correctly and being designed correctly. And then also a lot of time talking with our other product managers on the team to see that what we're developing in each of our own modules are, driving towards the core objectives of the company and also keeping in mind customer feedback. So spending a lot of time also thinking about how to build things that both are what customers want and what they've been complaining about, but also, does it meet the company objectives? So I would say that's most of my day typically. It's not uncommon to have like at least 3 to 4 hours of meetings a day out of like an 8-hour workday. So.
And would you say that your role is more above the level where you would be using data science tools directly at this point?
Yeah, so at this point, I don't really do any hands-on coding myself. The most I do is I also run a lot of SQL queries. But back when I was working more as like an analyst, used a lot of Python, specifically Pandas and PySpark, which are different. Pandas is like a package for like data analysis in Python, and PySpark is like a framework for analyzing and manipulating large data sets. And then also working a lot within the like AWS ecosystems, like spinning up different clusters and instances and running things on those instances. But I've kind of abstracted myself from all of that now, which is kind of what I wanted.
I'm glad to hear that it's desirable. That's great.
Yeah.
Okay, great. So thank you all. So the rest of the questions, not all of the panelists have indicated that they wanted to field, but of course, if any of you have any thoughts during, that come up in the conversation, don't hesitate. So this question is for Nick. And the question is, how does chemical engineering inform your work now? Is there a single chemical engineering class, elective or core, that's strongly related to what you do? And then more broadly, how do the broader skills and approaches, such as thinking across scales, analyzing systems, designing or working within constraints, et cetera, that you learn as a chemical engineering student, or from prior work experience, how do those inform your work now?
So I wouldn't say anything in particular in terms of the chemical engineering classes I took really informs my work right now. In fact, I don't. Most of Capstone actually, for their implementation engineers, typically hires mostly chemical engineers that don't know any programming, and the reason being is that we have the vocabulary to discuss and understand the types of problems that our customers have, which is just a very broad subject. But in terms of the types of skills that I learned, mostly, and I'll thank Thermo in particular for this, but actually really almost all of my classes, was that working. I work a lot in situations where I don't necessarily know exactly what's going on. I'm confronted with new problems pretty much daily from customers that don't necessarily know what the problem is. They just know what it looks like. Especially since I work with a suite of software that people are using to view their data, but it might be connecting to all sorts of crazy things throughout the mill. They just see a problem come up there, but that problem might actually be sourced in all sorts of places. So being able to deal with not knowing very much and then trying to find that out, and being able also to pull out what isn't useful information and what is useful information from the problem at hand, and then use that to solve an issue. Things like I remember Dr. Holt would put a lot of like red herrings in his problems that were just meant to be like, oh, this is information, but you're not supposed to use it. And the point there is that you're supposed to recognize what's good, bad information. And so that's really been something that I use a lot, especially most notably because a customer comes to you with a need, with an immediate problem statement that may not actually have anything to do with their more fundamental need. So figuring that out, why they're asking you what they're asking you, and then also how to solve that problem in your information sparse situation has been really useful.
I think not knowing what's going on is something we can all relate to.
Yeah.
I've also heard it said that it's a lot easier to teach an engineer to program than it is to train a programmer to know engineering. And I'm hearing that reflected in your answer. So great, thank you for that. Great, so this next question is for both Kate and Nick. And the question is, what are the biggest challenges in computing, big data, and digital technologies, in your opinion? And what do you see as the role that ChemEs play in addressing these challenges? So I'll let you start, Kate.
Yeah, so I want to get a little bit heavy here right away and say that that bias in data and bias in algorithms is a huge problem here, and it's something that needs to be talked about more, I think. There have been countless examples of people applying AI to solve all sorts of problems, and it turns out that the data set that was used was biased, and so they end up getting biased recommendations, all sorts of things. So there's so many different places where where human bias can enter into the pipeline, and so that's something that is really important to keep in mind when you are designing and implementing these pipelines. I really want to kind of hammer that home, and it's something that I do as a result think about a lot. And I guess moving away from that specifically, another problem that I run into a lot is is just scarcity of publicly available data. A lot of great data out there is proprietary, and especially if you're kind of working in this protein small molecule interaction space, drug companies have a lot of proprietary data there, and so that's something that can be kind of frustrating to deal with too. Is just this data sharing thing that could really help advance the field forward much more quickly, but is we're not able to do that due to so much of it being proprietary. And then another final challenge that I want to mention that's specific again to to this area that I work in with dealing with protein small molecule interactions is just that a lot of the sort of classical heuristic based like simulation approaches to that are very expensive, very computationally expensive, and they still have limitations. And so one of the kind of the exciting potential areas there is quantum computing, that there's hope there that can address some of those challenges, but that field is just not there yet. But I did, in my master's program, I took a quantum computing class, and that's something too where that's another area where I think ChemEs can really be useful, is kind of working at addressing a lot of those problems, and hopefully moving into spaces where quantum computing for a lot of this becomes more actualizable.
This is a topic near to my own heart as well, this problem of the simulations just not being there yet. And it's an exciting time in any kind of computational science right now, because with computing of all sorts, not just quantum, but especially quantum computing on the horizon, things are getting so much faster. And what was possible yesterday may seem quaint tomorrow. And it's only going to accelerate. So very exciting stuff. Okay, great. And Nick, the same question.
Yeah, actually piggyback on Kate's answer for a minute. Kind of what got me thinking on this was quantum computing. So generally, I'm not sure necessarily that. I think engineers as a whole, this is why you see finance people and people from all sorts of different industries at engineering fairs, is because engineers are really good about thinking about things. And so I'm not sure necessarily generally that a ChemE is going to be always more useful than someone else, except that chemical engineering is a type of engineering where very typically you're dealing with stuff that you can't see. Even people who say work in oil probably have never and will never see the inside of a distillation column. Things like that. So there's a lot of imagination that goes on because you can't touch what you're talking about, or what the theory is. These are thermodynamics that happen on a really small scale or something like that. So imagination is a really, really important skill that I think that chemies by necessity of their field have to have, and I think is really valuable for things like big data, where again you're dealing with stuff that you don't get to see, or is multi-dimensional problems that you just can't visualize, but instead have to be creative with, and I think that's really, really valuable. In terms of like other challenges, typically I think about things, of course, in terms of my job and data engineering. And I'd say one of the biggest ones is accessibility versus security. So typically big data might be in the cloud or something like that. And that data, to be useful to people, needs to come out of the cloud and needs to go into somebody's computer. And so, all along the way, there are points of failure, there are points of attack. In computer science and security, they have the term of sort of the area that you put onto the internet that is attackable, and so there's always this interplay between making something very accessible to many people and also making it secure. That is a real problem, especially when you have large sets of data that are in the cloud or otherwise just aren't localized to a certain place. And finally, also in terms of building things, generality versus utility. So something that's very general that is going to be very useful to a lot of people, the more general you make it, typically the less useful it's going to be. But a lot of places are going to want something that just kind of hooks up without a lot of maintenance. And that's not always going to happen, right? And so then the more specific you get something, of course, way more useful for a particular problem, but then is also less generally applicable. And so general design constraints like that are a real problem when you're trying to make something that's useful to a lot of people.
Great. Okay. Thank you so much. So these questions have been getting some great answers, so we really appreciate that, but we are going to be transitioning towards the open Q&A in a minute here. Before we do that, I just wanted to ask one more question to Sanchit specifically. And that is, can you talk to us about why chemical engineering appealed to you as a degree? Were you interested in data computing or digital tech field before deciding to do the ChemE degree, or did you learn about that area of impact over the course of your education?
Yeah, so I kind of stumbled into like the digital computing area. I originally was interested in ChemE because I thought I wanted to go work in pharmaceuticals and be like a process engineer for one of those companies. So a lot of my internships in college and like a lot of the like undergrad research that I did in Professor Nance's lab was like kind of geared at getting me there. Realized kind of late that it wasn't really for me. But I did stumble into this kind of digital aspect of ChemE. But I think what ChemE really did for me, and what I think is often overlooked in software in general, is if you come from a non-CS background, depending on the industry you go to, you may or may not have domain knowledge. But if you do have domain knowledge, like for me going into more of these healthcare companies, having worked in like kind of medicine related efforts, having taken a lot of bio E classes, that did give me that domain knowledge. So I feel like I was able to understand the problems that we were trying to solve a lot better than if I was just coming in blind.
Right. Yeah. Wonderful. Okay, great. So Elizabeth, do we want to go ahead and transition to the open Q&A?
Yeah, that sounds good. And I'll let you know. I'll just unmute or raise my hand to let you know if there's a question from the in-person audience.
Okay, wonderful.
We'll see if does anybody have questions? Yeah, we've actually got one. So if you want to say it, I'll repeat it, but I'm gonna leave the mic off just in case y'all can hear it. So I'll repeat for Kate. The question was, how do you mentioned bias in algorithm design? How do you go about in your day-to-day trying to minimize or reduce the amount of bias in the work that you do?
Yeah, that's a great question, and and that's something too that's a continuous learning process. I would say it really depends on the problem and the domain in question, but certainly anytime you're training or doing analysis on data, I've gotten into the habit of really looking at the source and verifying the data, because for certain projects I've done, there's this part that involves like web scraping from a lot of publications to kind of get as a means to gather the necessary data. And so unfortunately it's not very glamorous and it can be time consuming, but I've just gotten to the habit of actually really going through and verifying how that data was produced, and just making sure that that it is, I guess, what it claims to be. And I actually do regularly catch things that sometimes they're typos and I can figure out what's meant, but other times they're just things just seem a little iffy, and I end up maybe tossing some certain instances, as opposed to, or I guess, yeah, for algorithms themselves, that really, I think, to address that is just kind of diving in and getting a deeper understanding of the shortcomings of particular algorithms and also their strengths. So you really don't want to just kind of apply deep learning wherever, because it's kind of the cool sexy thing to do right now. It's there are instances where it's not actually useful. It can kind of obscure things that are going on in your data set. So my recommendation there is just to really understand that the particular strengths and weaknesses of the algorithms you're using, and then also just the types of data you're using.
I'm reminded of the comment Nick made about imagination being an important skill. We have to often imagine all the ways that bias can creep in when it may not at all be obvious or even visually apparent when if you plot the data, it doesn't look biased.
Yeah, absolutely.
Great. So we have another question that is for all of our panelists, so whoever wants to take this. The question is, how much of the tools and skills that you're now using did you get while you were in your undergrad degree versus getting that training on the job?
I'll pipe in here and say that so the technical skills, very little. Programming I didn't really learn a lot of in my undergraduate, and so almost all of that was done on the job. However, a lot of my undergraduate that was sort of outside of ChemE specifically, but actually even parts of ChemE, like I was AICHE president, things like that. Leadership skills and interpersonal skills and oratory skills were things that I worked on the whole time and were valuable, and I still work on them today. Furthermore, also just sort of a love for and ability to learn, because just about every day I'm learning something new. So those have been really important and valuable skills that I got. But in terms of and this is also reflected in a lot of my peers who've gone into vastly different areas, like logistics and computer science and things like that. Is that a lot of it is just learning how to think, learning how to think about problems, being comfortable not knowing everything, being okay to say I don't know sometimes.
Yeah, I would echo what Nick is saying. I think the biggest thing that came out of ChemE for me was like problem solving skills. Really taking a problem and breaking it down into what do we want the output to be and what are the inputs, and figuring out how to go from there. For me personally, I do think I got a little bit of training for the technical skills. Like I personally did branch out and take some CSC classes. One of my I think last projects in lab was like helping do some data analysis. And so I think I did get some practice there, but most of that was on the job.
Yeah, and I'd add too, I liked what Nick said too about, even skills that were acquired outside of the classroom. I think that was a big thing for me as well. And then also just taking opportunities like, like special design, for example, for senior capstone. I learned a lot of real world problem solving skills doing that I wouldn't have gotten as much just through traditional coursework, just due to the limitations that are inherent with that. And then all the other extracurricular activities I took advantage of as well, like women in ChemE and different sorts of events and things we did with that. Those all ended up actually being really valuable in different areas, and and even actually helping me get positions and making me a better candidate as well.
Wonderful. Yeah, I am not a panelist, but I would agree with everything the panelist said in terms of the broader impact of the coursework is often not apparent at first, but then you see the things that you learn end up being really useful in all sorts of ways. We have another question specifically for Kate, and that is, what was your motivation in going for a master's degree?
Yeah, so I briefly alluded to this, I think in my intro, that at the time when I was doing undergrad, there weren't really options for data science focused coursework yet. And I do believe those are in place now, which is awesome. And so, I definitely recommend anyone who thinks they might be interested in that in data science, take advantage of those. So I had a few options because I knew I wanted to go in this direction. Getting at least a master's was definitely the best option for me, since I lacked a lot of those technical skills that I needed. So there was, the option between going more traditional CS and then focusing where I wanted, or going for a data science specific program. And I talked to a lot of people and got advice there. And the reason I went CS was that it does provide a bit more flexibility in case, I do end up wanting to work just as, a software engineer, for example, or, kind of go into a more traditional role that way. Being data science focused specifically can narrow those opportunities slightly, but I was still able to obviously go into data science with a CS background, and then and I just gained a lot of other skills that have been useful in various ways too, from more classical CS focused classes, and then having that combination of backgrounds, the CS and the ChemE, really enabled me to pretty easily and quickly get a co-op in an interdisciplinary field that I was interested in working in, and really be able to make the most of that experience.
Great, thanks so much. We have another question for Nick. What led you to moving overseas? Were you interested in living abroad, or was it more of a career move opportunity?
It was both. So as an implementation engineer, I had the opportunity to go to Europe a few times for customers and doing on-site visits. And during that time, I developed an interest to be here. And so I talked to my manager about opportunities there. And that was actually, it was about 2 years between that conversation and actually getting a position that ultimately moved me here. And the other part was too that also, I really do enjoy the tactical work that I do. I'm certainly more of a, I guess, abstract thinker. I like to mentor. I like to lead. I like to do things like that. And so where I was really going to be a path towards more technical work that I didn't really want. My career trajectory, I really wanted to be more in engineering management, things like that. And so transitioning over here was also a career move to sort of set my career on a new trajectory towards something that I thought would be more fulfilling. And also, you get way more vacation over here too, by law. It's great.
Lots of advantages to Germany for sure. You were saying also during the while we were chatting before we were audible to everyone that you really like having problems.
Yes.
And
yeah,
I think that's something we can all learn from.
right, immersing yourself in a new culture is definitely, every step of the way. You look at a traffic sign, and that's a new problem because there's a lot of traffic signs that I don't understand.
Right.
So
Relatedly, in the
something you gotta
chat,
do.
someone asks if you speak German.
I do not speak German. I speak very little German. I speak kind of enough to get by. I can order stuff from a restaurant, whatnot. I cannot navigate the labyrinthine German bureaucracy. I expect to at some point, but for now, no, I haven't needed to. It would be certainly useful, but no, I don't.
Okay, great. We have another question that is for all of our panelists, and that is, what are your future career goals, or where do you want to go to grow, within your field? What do you hope to contribute to or accomplish? So how about Sanchit first, and we'll work around.
Sure. Yeah, that's a good question. I think for me, I definitely want to stick to product management. I think this is what I enjoy doing and what I can see myself doing long term. So I think for me, it would really be in terms of continuing to climb the corporate ladder, I guess, per se. Would love to get to like the director level, director of product management, and really oversee, a product or a suite of product and being in charge of the strategy for that. In terms of what do I hope to contribute or accomplish, I would say, to me, like the greatest feeling is when you launch a new product or a feature for a product, and you see people using it, and you see people excited about using it. And I think that's really what keeps me going. So I think doing that on a much larger scale is where I hope to be.
Great. And Kate?
Yeah, so I am starting to move in the direction that I do, want to go in for the remainder of my career, hopefully, which is balancing technical work and then PI type work, leading projects. And I really I've discovered, both of those things, they both, offer some different benefits, and I really like having the opportunity to actually be in both of those roles and move back and forth. That's something that is really nice about working at a national lab is you do kind of get that fluidity just between projects and even within specific projects. So I do want to keep moving in that direction, certainly. And then otherwise just doing continuing research and work that that has impact. That's something that drives me a lot. So for example, some of the projects I've worked on recently are ones related to COVID. So we've been finding new ways to target SARS-CoV-2. And I've been collaborating with scientists at Oregon Health and Science University to find new targeted therapeutics for various cancers. So just getting to work on a lot of those different projects that that feel like they do have impact and help people. That's something that really drives me, and something that I also want to continue to be able to do and grow in those roles as my career grows.
Wonderful. And Nick?
Yeah, so where I really would like to see my career go is more towards strategy and again management on a higher level. Of course, I really enjoy mentoring people and passing on knowledge and managing people and helping them reach really high potential. So that's kind of where I'm hoping to go in the short term, and then in the long term. I'm a really big fan of strategic thinking, of having to deal with problems on a very large scale that touch a lot of different things in terms of business strategy and things like that. So so that's where I'm trying to get my career to go now, which part of it's in product development. It's keeping your finger on the pulse of how your industry is going and what people need in it. And so that's what I've been pushing for, and I hope that's where I would get to, but we'll see.
Yeah, that's great. One of the best pieces of advice I received when I was an undergrad myself was that it is a feature and not a bug that your career trajectory will be very nonlinear. Oftentimes, we end up not knowing where we're going, and that's a good thing.
Sorry, I was at
Please.
a talk at Boeing where a woman was talking about her career path, and she was kind of an executive in Boeing, and what she had said that has always stuck with me was that, you know, whenever a door opens, whenever you see an opportunity, consider it, because you know your life can take vast, interesting changes by some really neat, really cool opportunity coming up that you never expected was going to be there for you. So yeah.
Yeah. Oh, I like the way that's phrased. Consider it. You don't have to say yes, but you should at least think about it.
Exactly.
I like that. We have a question now for Sanchit. It says that you said you changed your mind from pharmaceutics to data science. When did you realize that you didn't want to do pharmaceuticals? And did you then go about, how did you then go about getting your first job in the data area? And then also to the other panelists, to everyone, I suppose, did you change your mind about what you wanted to do at any point? So that relates to what we were just talking about. Go ahead, Sanchit.
Yeah, for me, I think I realized when I, kind of came to the realization that I was doing more or less the same things every day, and to me that became a little bit monotonous. So the thing with pharmaceuticals is that, especially in like drug development, which is what I was kind of gearing towards going into, these projects are like, big commitments, right? Like they can span easily 5 to 10 years at least. And so to me, the thought of doing, very related things, obviously you're not doing the same thing day in, day out, but, very, very, very related. To me, I realized that just didn't really appeal to me anymore. And so, getting into product management, I think, every day is a little bit different. Like I think I alluded to this in some of my past answers, but, one day you might be like hammering it out with designers and like, defining what the UX should be for a certain feature. One day you might be talking with, the software engineers to see like what the trade-offs are from implementing something a certain way. Talking with marketing to see what the launch strategy should be. So I think the day in, day out of doing different things and focusing on different things was really what drew me to that. In terms of how did I go about getting that first job in the data area, I had an internship at that company between junior and senior year of college. I was fortunate to have done well enough that I got a return offer, and so that's how I got
that. Great. And so the other panelists want to take a crack at, did you change your mind at what you wanted to do at any point?
Yes, at many points. That was kind of a theme, I would say, of my undergrad experience. And by the way, too, like I started out actually as an English major in undergrad before doing a 180 over to ChemE. But it turns out that actually even those skills have been really useful. One of the reasons I got an enthusiastic offer, to come on as a staff scientist was my writing skills, because I'm in a place where publishing is important. So yeah, there have been many different points of changing my mind, and I really feel like all of that though has actually has played various roles in getting me to where I am now. So definitely don't be afraid of of changing your mind. You can always do that and go down a different path, and again take new opportunities, or at least consider them, as Nick said, before that come your way as you go along.
Yeah, I would say probably the first several years of my work in CS, data science, I constantly thought about changing, because I thought that I would also be fairly fulfilled by a more traditional chemical engineering job, and I wasn't getting it, and I was often worried that I was going down a path that wasn't going to fulfill me in that way. And to be fair, I don't think of course you're never going to get to know what that opportunity is going to be like, because that's what opportunity cost means. And so you may always think about that foregone conclusion. That being said, I think I love the one you're with, right? I started angling more into this direction, and it seems like I'm going to stay there, and that's fine, and I'm enjoying it, and it's fulfilling. But yeah, I would say it's yeah, a lot of questions about that for me.
I think that's normal in my opinion, anyway.
Mm-hmm. Oh yeah.
Okay, we've got one more in-class question, and we're running out of time, so I'll just ask the panelists if they want to take it real quickly. So the question is, I like this question. What is the biggest professional mistake you've made? It's a tough one for sure.
I will take a stab here, and this is definitely directed specifically at women who are here, and also, you know, anyone who's part of an underrepresented group. Not negotiating in the way that I should have. That's something that's really, really important. And I was led to believe that specifically for my role in, in a government job, that there wasn't really room to negotiate, which was not true. There actually is. And so just, I guess, advocate for yourself, do your research. That unfortunately that is something that's definitely necessary. So, that's less related to my specific profession, but just, general professional advice is, is do your due diligence and advocate for yourself during the negotiation process.
Yeah, to piggyback on that, I negotiated for my first position, so don't be afraid to do that. It was outrageous, but like I got more, so it's there's no harm in asking. As far as my biggest professional mistake, actually, I can't say I've done something like particularly huge. I do remember it was when I was looking for an internship, and really I was just looking for anything, like whatever would stick. You know how your senior year goes, your junior year goes. It's rough. And I remember answering basically as such to someone who's like, hey, what are you looking for? I was like, I'm basically looking for anything. And this guy, as that person left, somebody else was listening to my conversation. Guy who was listening to my conversation turned to me and said, and just like tore me down because and ultimately his message was, why would you say you'd take anything, right? You should be talking about what you want from them, or like why you want to work with them or for them or in their field, not just thrown out there. That's nobody's going to bite on that, right? Yeah. So that was a really useful piece of advice.
Yeah, for me, I would say, I would say, basically, don't be afraid to, make changes if you aren't being fulfilled at your current role or position. I think for me at my first company, I was feeling like I wasn't really getting what I wanted out of it for a while. But I think I was just comfortable, right? I'd been there for a while, kind of knew the ropes, was kind of easy to just get by. But that wasn't good for anyone. So I would say, it's okay to take yourself out of your comfort zone and push for something that you really want to do. Yeah.
I'm learning. This is very helpful for me. I'm glad to have this opportunity to hear these things from you all.
We'll mention one more thing about negotiation too, is that everything is negotiable. And I think if anything about the last 2 years have taught us of pandemic life is that our relationship with work is often really unhealthy, and that we don't think enough about ourselves and our lives. And that's a lot what a negotiation can give you. That's you telling someone else what your needs are and setting boundaries for yourself. And those are really important. And yeah, every opportunity you get to do that, you should.
That's right. Okay, so we are out of time. So thank you, panelists, all for these really engaging discussions. And I have been asked to remind everybody in the room to complete the reflection survey at the end.
We'll give you a round of applause in here.